This is the part 2 for chapter 23 on the lipid. We're going to look at really the fatty acids and their esters. So fatty acids are long end-branch hydrocarbon chain with a carboxylic acid group at one end. Most of them have an even number of carbon atoms. Those containing only carbon-to-carbon single bonds, we call those saturated fatty acids. When you have one or more carbon-carbon double bond, they are known as unsaturated fatty acids. So this is what it looks like. This is here a saturated fatty acid, palmitic acid. You see you only have single covalent bond between the carbon atoms. And then the one at the bottom is an unsaturated fatty acid, linoleic acid. And you look at here, the arrow shows you where the double bond exists. So that is very important because it's going to give some of the properties. Now, chemists usually use a shorthand nomenclature of fatty acid that avoids using the common name. Most of the time what we use is the carbon, C for carbon, followed by the number of carbon atoms that are present, a column, and then the number of unsaturated bonds that are present. Polyunsaturated fatty acid, they have more than one double bond, and the number of double bonds present in a fatty acid is the degree of insaturation. So those are examples. Palmitic acid, C16 column 0. That means you have 16 carbon atoms attached and there is absolutely no double covalent bond. Oleic, C18 column 1, and linoleic acid, C18.2. That means that you have here for the first one, oleic, one double bond, and the linoleic acid, you have two double bonds. So take a closer look at that table, and typical source where you find them, coconut oil, butter, fat, all of those. Common name and then number of carbon, and you look at the condensed formula, but then the condensed notation, C12 column 0. So you have here 12 carbon atom and no double bond. You go down, unsaturated, oleic, olive oil, C18 1. That means that you have 18 carbon atom and one double bond. Go down to the arachnoid that you find here, C18 column 4, 4 double bond that exist. And when you look at the melting point, you see that the largest amount of unsaturated, so the largest amount of double covalent bonds you have, the lower is the melting point. Looking at waxes, this is a mixture of fatty acid and long chain of alcohol ester. Most of the time they have an even number of carbon atoms, from 16 to 36. The alcohol have an even number of carbon atoms from 24 to 36. Here just an example, long chain of alcohol and long chain of acid. Some example here, beeswax is the ester formed from 30 carbon alcohol and 16 carbon acid. That's very important because that's most of the time that waxy protective coating on most of fruits, berries, leaves, and animal furs that have similar structures. This is here an example. Aquatic birds have a water repellent waxy coating. When cut in an oil spill, the waxy coating dissolves in the oil and the bird lose their buoyancy, so they will drown. Looking at another type of fatty acid and ester, triacylglycerol, animal fat, and vegetable oils are the most plentiful lipids in nature. Difference: animal fat, an example is butter and lard, are solid. Vegetable oils, corn, olive, soybean, they are liquid. Well, this has to do with the room temperature. So we're talking about mainland room temperature because, of course, in Hawaii, pretty much everything is just liquidish. Triacylglycerol, all fat and oils are composed of triester of glycerol, and they are also known as glycerin with 3 fatty acids. We name them chemically as triacylglycerol, but many times you will read the name triglyceride. Those are some examples. Here you have a glycerol and 3 fatty acids. The three fatty acids are any specific triglycerol are not necessarily the same, and you have here some example. Top saturated, second unsaturated, and third unsaturated. So those triglycerol, where vegetable oil are mainly unsaturated fatty acid. Animal fat have a large percentage of saturated fatty acid, and we're going to see the properties on the next part of that lecture. This is going to be that single bond or double bond is going to make the molecule either more compact or more loose, and that's going to also give you here the reason for the different melting points of fats and oils. So look at this, animal fats versus vegetable oil, and look at here the approximate composition of those fats and oil, number of carbon atom, number of saturated or insaturated, meaning double bond between the carbon atom, and the more double bond that you have, the lower the melting point, meaning that insaturated fatty acids are going to be liquidish at room temperature.